Hi everyone, in this video we're going to go over the 2009 AP Physics E Mechanics Free Response, question number 1. So the question asks, a 3 kilogram object is moving along the x-axis in a region where its potential energy as a function of x is given as u of x is equal to 4x squared, where u is in joules and x is in meters. When the object passes a point x is equal to negative 0.5 meters, its velocity is 2 meters per second. All forces acting on the object are conservative. So part A asks us to calculate the total mechanical energy of the object. So if you remember, E is equal to U plus K, and U is the potential energy, K is the kinetic energy. In the question, it gives us that U of x is equal to 4x squared. The general formula for the kinetic energy is half mv squared. And they give us in the question that x is equal to negative 0.5 meters and v is equal to 2 meters per second. So you can just plug that into this equation. Plug in x here and v here, and they give us that the mass is 3 kilograms, so we can put 3 kilograms at m, and once we plug all of that in, we get E is equal to 7 joules. So the reason we can just plug in the data that they give us is because the energy is conserved in every point in the motion, and that's because all the forces acting on the object are conservative. So the energy at negative 0.5 meters is the same as the energy would be at, say, like 1 meter or 2 meters. So we can just plug in these values and we'll find the energy at that point, which will be the same as the energy at any other point, because all the forces are conservative. So part B asks us to calculate the x-coordinate of any points at which the object has zero kinetic energy. So when k is equal to 0, E is just equal to u. You can look at this equation here, and if you plug in 0 here, E is equal to u. And u, as given by the question, is just 4x squared. So we have that the total energy is 7 joules, as we found in part A. So we just put that here. We have u is equal to 4x squared, we solve for x, and we get that x is equal to 1.3 meters. Part C asks us to calculate the magnitude of the momentum of the object at x is equal to 0.6 meters. So the general formula for momentum is P is equal to mv. M, as given by the question, is 3 kilograms. All we need is v. So we have here that x is equal to 0.6 meters. And if you recall, the formula for energy is E is equal to k plus u. And if we isolate k, we get E minus u. And why do we want to do that? We want to find v. And k has v in the equation. And you'll see in a minute why this is useful to us. So we have this equation, E minus u is equal to half mv squared, because both of these terms are k. If we make those equal to each other, we get half mv squared is equal to E minus u. And E minus u, if we plug in the values, we'll get E is 7 joules, as we found in part A, and minus 4 times 0.6 squared, 0.6 is just x, and we'll get 5.56 joules. We can plug that into here and solve for v, half mv squared, and we'll get that v is equal to 1.92 meters per second. And here I just did the math. 2 times 5.56 divided by m, and then all of that's square rooted. So once we found v, we can just plug that back into this equation. P is equal to mv, and m is 3 kilograms, v is 1.92, and that's all equal to 5.8 kilograms meters per second. So part D asks us to calculate the magnitude of the acceleration of the object as it passes x is equal to 0.6 meters. So this formula, force is equal to negative du over dx, is going to be used in this part, and that's because that's one formula that relates the acceleration to the potential, and that's because we'll see here that F is equal to ma. So if you take the derivative of the potential, 4x squared, I just showed you here this 2 goes down over here, and you'll get negative 8x to the first power because you want to subtract the exponent by 1. And so then the force you'll find is equal to negative 8x. And so Newton's second law is equal to, says that F is equal to ma. So ma is equal to this. So here we can solve for a is equal to f over m, and then plug in this for f, and we'll get a negative 8x over m. And then you can plug in all the values that we have, so 0.6 meters, 3 kilograms for m, and you'll get 1.6 meters per second squared. Finally, for part E, it asks us to sketch graphs of the object's position x versus time t and kinetic energy k versus time t. And we have to assume that x is equal to 0 at time is equal to 0, and the two graphs should cover the same time interval and use the same scale on the horizontal axes. So if you look at the formula for u, you can see that u is equal to 4x squared. And that is the same typical equation of a spring. U is equal to half kx squared. That's the general formula for a typical spring. And as you know, the solution for half kx squared in spring motion, a spring always follows the general formula x is equal to a sine of omega t plus phi. So any sine graph will do here because we're just sketching, because we want to just convey the motion of a spring because of this potential energy function. So all we need is a sine graph. You want to just make sure it starts at 0. T is equal to 0 and x is equal to 0 because that's what they say here. And then we can just follow anything. We have to make sure the amplitude is the same because we have no resisting force or anything like that. We just want to make sure it has like constant motion. And then here they want us to graph the kinetic energy. So E is equal to U plus K, as we know. And then if we solve for K, we'll get E minus U. So what is happening? So the points that we want to look at are the points where this graph crosses the t-axis. So every time x is 0, like right here, and there, and here as well, every time x is equal to 0, the potential energy is going to be equal to 0 because it depends on x. So you plug in 0 there, you're going to get U is equal to 0. So then what happens to energy? Energy is equal to U plus K, but if this term is 0, all the energy is given by kinetic energy. So at those points, kinetic energy is at a maximum. It makes up for all the energy. And remember, because energy is constant. So if there's no potential energy, kinetic energy is going to make up all the energy. It's going to be at its maximum when x is equal to 0. So at every point you see right there, and right here, you want to make sure that kinetic energy is at its maximum. So right here, and all of that. Where kinetic energy is going to be at a minimum is when x is at its maximum. Because then you look back at this, when x is at its maximum, U is going to be at its maximum as well, which means most of the energy in this equation is going to be made up by potential energy, and very little will be made up by the kinetic energy. So at these points, it's minimum. Like when all the energy is potential energy, kinetic energy is going to be 0. So right there, and here, kinetic energy will be 0. And it really doesn't matter if x is negative here and positive here, because here ultimately it's 4x squared. So even if it's negative, you plug in a negative value here, it's still, the overall term is still going to be positive, and k is still going to be 0. So that's all for this video. Thank you for watching.